Hi there, this is Srikanth Sari. So in this lesson, we are going to learn about the basic data types in C programming language. So first let me launch the IDE, which is Turbo C. Okay. So in the last lesson, we have discussed in detail about the various different rules to define a variable. So now let's focus on our intention to learn about how to use that variable to declare using how to make use of that variable to declare a data type. Okay, so here so first let's save this program. Let's say it as types.c. okay, so let's write all the basic things like header files. Okay, hash include studio.h, hash include conio.h. okay, so void main, so all the basic stuff. As we are writing get ch, let's keep it also. Okay, so there are 4 basic data types in C. The first one is int, the second one is char, the third one is float, and the fourth one is double. Okay, so these 4 are considered as primitive data types in C. Okay, so from using this basic data types, you can make user-defined data types or derived data types, which we will see in the subsequent lessons here. Okay, so what is an integer? So integer can take it as a numerical. Okay, so numerical values are represented as integers with the data type int in C. Okay, so you can take a number which is between a number or a combination of numbers between 0 to 9 are known as integers. Okay, so first let us declare a variable for the type integer here. So let's say the name of the variable as my int. Okay, so this is a variable which is of type integer here. Okay, so if you want to assign some value to this variable, you can do it when you are defining a variable directly like this. Okay, so int my int is equal to 10 here. Okay, or else you can take another variable like this, my int 2. okay, so you can do it first. You can define the variable and then you can assign some value, some different value to it in the next statement here. Okay, so both are one and the same. You can do it when you are defining a variable directly, or else you can have at first define the variable and then you can initialize some value into it. Okay, so integers, whenever you are writing doing programs in future, so integer is used to store the numerical values. Again, integers are used to store the numerical values such as roll numbers. So for example, if you're writing a C program of handling a student database, so there you can, if you want to store a value called roll number. Okay, so roll numbers normally it is varying from normally they are like digits like 1, 2, 3, 4 plain digits or numbers, numerical values. Okay, so in that case you can use integer values. Okay, so if you want to see what which value is stored inside this integer value, so you can make use of printf statement, which we have seen in the last lesson. So you can say have a small statement also, the value of int or integer, the value of integer my int is equal to %d my int here. Okay, so first let us run the program and see what is the output here. Okay, so we get the value stored in the my int variable here. Okay, so here if you observe, we have used a new the printf is entirely different of what we have did in the first lesson here. So here the printf uses a format specifier. Okay, so here the %d is the format specifier for integer of the type integer here. Okay, so if you want to print a value which is stored in an integer variable, a variable of type integer, so you need to use this format specifier. Okay, so %d. So that you have to keep in mind whenever you make using of printf statement to print some values. So corresponding to that that integer value, how many integer values you have to use that many times that format specifier. Okay, so in the same statement, if you want to print the value of both my int and my int 2, so you can have a statement, a new statement here, myInt2, and you can want to say, so myInt is equal to, you need to use the percentage d for first myInt and next percentage d for the next one here. Okay, so two different times you need to keep that percentage d format specifier here. Okay, and again at the end of the, after closing the quotations here, so you need to write that variable also, myInt. So it's going all the way down here. Okay, that's no problem. Let's scroll it up. So myInt and myInt2 here. Okay, so now if you run your program, so you get both. Okay, since we are not using the CLR SCR statement, so it's coming twice. Let's keep clear screen at the beginning here. Okay, okay, since we are using a Turbo C compiler, to not allow the clear screen before the variable declarations, this is one of the limitation here. Okay, so here I get the output as myInt is equal to 10 and myInt2 is equal to 20. So how we did this? So if you go to your program, okay, so here we have just had a message. Okay, this percentage d, so here this percentage d corresponds to the first integer variable, which is myInt, and this percentage d corresponds to the second integer variable, which is myInt2 here. Okay, so that's the way you need to follow in order to print the value of using in order to print an integer value here. Okay, so let's take let's go into next data type, which is char here. So in order to declare a character variable, so you need to make use of this keyword char here. Okay, so there are, as we have discussed in the first lesson, there are 32 keywords in ANSI C specification. So which has so every keyword has some reserved and specific meaning here. Okay, so here character, so let's take a variable for character here, char, let's say mychar here. Okay, so char mychar is the name of a variable, and let's assign some value to it. Mychar is equal to, so when you are assigning some value of type character, you need to keep one thing in mind, which is you need to assign that value inside this quotations here. Okay, so if you say something like this, so S is a character of type character. Okay, the compiler understands that by seeing those single quotations here, the compiler understands that this is of type character here. Okay, this is very essential. So later when we there is another variant of using characters, which is known as a string, which is nothing but a group of characters. So we'll focus about the strings in the subsequent lessons. So for the time being, you keep we have to study like this. Character is the one which is wrapped inside a single quotations here. Okay, so mychar and we have a character S stored in the variable mychar here. Okay, so now let's make use of this printf statement once again. Let's print the value also. So printf /n/t, the value of, so all these messages are just for understanding purposes. The value of character mychar. So now the format specifier changes. So since we are trying to print the character value here, so the format specifier for character is %c here. Okay, so %c and the name of the variable, which is mychar. So now if you run your program, we have an error here. Okay, so what is the error? The declaration is not allowed here. Okay, so let's keep it down if it's having a problem. myInt2 is equal to 20 here. Okay, so you have the value of mychar SS here. Okay, so whatever the character you want, the characters in C are like 0 to 255 here. Okay, we have so anything you can take it like a character like this. Okay, so character set in C comes like this, 0 to 9, and alphabets from A to Z in lowercase, and alphabets from A to Z in uppercase, and followed by the special symbols like dollar, percentage, ampersand, asterisk, and exclamatory, so on and so forth. Okay, so all the special characters are very essential. All the special characters fall under the special characters in numericals from 0 to 9 and small, and letters corresponding from small a to capital small a to small z and capital A to capital Z, followed by all the different various characters. So combined total, this would be as total 255. Okay, so 0 to 255. So 0 to 255. Okay. So here, so this is nothing but just a comment here. So comments in C++ can be a single line comment, okay, or else you can have if you're well having the knowledge of C, you can have a comment like this also, okay. So this is the character, okay. So instead of plain S character, you can have something like this, a pound sign or at sign, something, whatever you wanted. So if you run your program, statement missing semicolon here, okay. So we didn't end our statement with semicolon, that's showing it as an error, okay. So you get the add symbol here, okay. So that's the story about a character here. So let's next move to the next data type, which is float. So let's take a variable to float here, my float. Let's say my float and assign some value to it. Let's say, so floating point values are quite different from integers, okay. So floating point values or the type, if you say a variable is of type floating point, it's having the capability to handle not only integers but also the fraction part, okay, which is the decimal part, okay. So here if you observe with an example, my float is equal to, let's say, 3.14 here, okay, the value of pi, okay. So here the normal integer, if you declare a normal integer like my int, it doesn't have the capability of handling floating point values here, okay. So even though you use something like this crazy, and if you run your program, so it just displays it as 10 here, okay, it just displays it as 10. So not having the capability of handling fraction values with a decimal point here, okay. So let's make use of printf statement and let's print the floating point value also here, the value of floating point, say, don't say floating point value, floating point variable, my float. So all these messages are not mandatory, so all these things are written for understanding purpose, okay. You can just have a printf statement %f and you can have the variable directly. So %f is the format specifier for the floating point data type, let's say my float here, okay. So now let's run our program and see what happens here, okay. So you get the value of the variable which holds the floating point value, but it is quite different here, okay. So in the program you have assigned your value to 3.14, but if you check the output after pressing the Control F9, so here you are getting a 3.14 followed by 4 consecutive zeros, okay. So this is because the default precision value of a floating point variable is 6, okay. That means that the precision is the one, the precision means the count, okay, the count of the number of digits after the decimal point here, okay. So default 6, so default precision, let's write here as a comment, default precision for floating point is 6, okay. So default precision value, okay, the default precision value, let's say value here, okay, for floating point is 6 here, okay. So here, even though if you assign the value as 3.14, you get the total after the decimal digits, you observe here 6 digits here, okay. So in order to control the precision, so you need to make use of this small adjustment here. So if you say .2f, that means that here you are explicitly saying that you need to display just 2 digits after the decimal point here, okay. Now if you run the program, so you get the exact value as 3.14 of what we have mentioned here, okay. So if you say 3f and if you run your program, so you get 10, okay. And next, let's move to the last data type, last basic data type, which is double. So let's first declare a variable for that, okay. let's declare at the beginning only, since we are not. So let's say double, let's say my double here. Okay, so let's assign this double and the floating point are one and the same. The only difference for the time being, you keep in mind that double has a higher precision value and a larger and a wider range here. Okay, so higher precision, so as we have studied that the floating point allows until 6 digits as its precision value. Okay, but the double has a precision value of 15. So whenever you are doing some scientific calculations of on a large scale, so you need to use that double data type only. Okay, so in that way you can achieve the more accurate value. Okay, so more about the double and float difference we'll see in the subsequent lessons when we study about typecasting. Okay, so for the time being, let's declare a variable. Since we have declared a variable for double, let's say my double. Let's assign some value to it here. Okay, so my double is equal to, let's say 3.1 2 3 4 5 6 7 here. Okay, let's make use of this printf statement once again. Let's print the value of double data type variable my double. So my double is equal to percentage LF. So there is a difference between even though we are using F for floating point variables, you need to use dot LF for my double here. Okay, so double here. Okay, so double dot percentage LF is a format specifier for double data type. Okay, so let's have the name of the variable here, my double. Okay, so now if you run the program, we're having errors. Okay, we have just misspelled the variable name here. Okay, one more error. Oops, missed the semicolon. So here you have a problem here. Okay, so why? So let's see here. Okay, so what is the problem? Okay, so here we have both float and double data types declared here. Okay, so now if you run this program, so in float variable we have assigned the value 3.14, and in the double data type we have assigned the value 3.1 2 3 4 5 and 6. Okay, so we have a greater value, more number of digits after the decimal point here. Okay, so now if you run the program, so you get the output so as you expected, except that in the floating point variable you get some trailing zeros. That's because, as we have seen earlier, so you can control the precision here. So if you make it dot 2f here. Okay, and if you run the application, run the program, so you get the exact value, so which we have stored. Okay, the main difference between the floating point and the double data types is that the floating point data type has a lesser precision value, which is 6 by default. Okay, so double has a higher precision value. That means double allows the more number of the decimal values. Okay, that means that in the fraction part you can have more values, more number of digits are accepted in the fraction part of your number here. Okay, so okay, the only difference, as we have learned that the float and the difference between the float and double is that the double has higher precision values rather than when compared to float. Okay, so float by default it takes up to 6 digits as precision value, and double has a higher precision value up to 15 digits here. Okay, so to demonstrate this with an example, so let's make both of them as same here. Okay, so 1 2 3 4 5 6 7 and 8 and 9. So we have taken too many values after the decimal point here. Okay, so now if you run the program, so you get some weird results here. Okay, so that's because if you observe in the my float, the value stored in the my float is not the value we have got here. Okay, so that is because the default precision value for both float and double data type is 6 here. That's what we have written in this comment here. Okay, so in order to change, in order to get the exact value, so which is not possible with the floating point, since we have stated that float accepts only until 6 digits. Okay, so that's the reason here. So if you run and see the program, so after 5 it's the remaining part gets truncated. Okay, so after 5 the whole thing gets rounded off and it's making it as 7 here. Okay, so in the same way, the same thing applies for double, since both the default precision value is 6. Okay, so now you can change this, even though you change both of the precision value for both the float and double. So if you change it as 9, dot 9 and dot 9 here, okay, since we are having 9 digits after the decimal point here. Okay, so now if you run the program, so there is a problem, we didn't save, compile and then run here. Okay, let's see what's the problem. Okay, so if you observe the program here, so for the floating point and the double values here, okay, so in the double section you get the exact value of what you have stored in your double variable here. Okay, so but the floating point value, it shows some weird results. If you see the output here, see after the 5 decimals, in the case of floating point, everything is getting rounded here, and it's also showing some different value. Okay, so that's because the float does not accept the decimal values or fraction part only up until 6 digit precision value. Okay, so that's not in the case of double value here. Okay, so only thing you have to keep in mind is double is more accurate than float. That means that you get the exact value of your computation if you use only a double data type here. Okay, and also double has a higher range than floating point values, so it's always advisable to have a double data type instead of having a float when you're doing scientific calculations or which needs a higher values in fraction part. Okay, so to summarize here what we have learned, that there are 4 basic data types in C, which are int, float, char and double. Okay, so int is nothing but an integer or a numerical, which is a combination of let's write it in here. Okay, so int is a numerical data type. So okay, int is a numerical data type which is a combination of 0 to 9, so which is a combination, or else can have a combination of 0 to 9 digits. Okay, so to be more specific, 0 to 9 of digits combination can also be called as a decimal integer. Okay, so we'll see various variants of integer types in the subsequent lessons. So also we have studied about char data type here. Okay, so char is nothing but which can be anything according to the character set of C, the 0 to 9 digits, A to Z alphabets and capital A to Z, and followed by the special characters like ampersand, star, percentage, asterisk and everything. Okay, and float and double, and also we have studied about float and double. So float and double both hold the rational values or the integer values, which is a combination of integer value and a fraction part here. Okay, so double is also same thing. The only difference is the double has a higher precision value and it has a more wider range. Okay, so see you in the next lesson. Goodbye.